Hi students, now I will talk about the free falling objects. We solved in a previous example a free falling problem, but now we will take it in more detail or more examples. For a free falling object, any falling object to downward freely like this in this way, okay, if I throw it like this or just I leave it to just go downward, all the falling objects are going to the center of the earth, okay. It's the direction of this falling is to direction of the center of earth, okay. The acceleration of these objects is always downward to the center of this planet, okay. Or if we are on another planet, for example, for on a moon or on Jupiter, not on Jupiter, on Mars or something like that, it will be downward to the center of that planet. We need to be note that there is a velocity is equal to zero at a certain point. There is a velocity equal to zero at a certain point. For example, at this in this experiment, this point the velocity is zero, the starting point. But if I throw the pin upward, it reaches a maximum height, then go back down. At the highest point is the velocity at the highest point is zero in this case. We will see that in example. The acceleration is equal. We will name it g, due to gravity. It is equal always 10. I'm sorry, it is not 10, but approximately equal to 10, but it is equal to 9.8. Be careful. You can solve it. Solve the examples. An example using it as 10. I solve the examples using g equal to 10. You can use it 10 and or 9.8 meter per square second, but it is always downward, always downward, okay. We have to choose a suitable direction. That means we need to choose the downward, even negative or positive. That depend on the problem. It is our example or our problem. We can choose the direction as we need. The mass of that object will not affect the motion, even it is light or heavy. It will not affect the motion, okay. You will see the experiment of free falling body for the hammer and the feather on moon surface, also in a vacuum room. The free fall is the same for both bodies. We have the main three equation of motion. In x direction, v2 is equal to v1 plus at. v2 square is equal to v1 square plus 2ax. X here is the change in position in x direction. The velocity v2, v1, v final, v initial, it's the same. Also the final position is equal to the initial position plus v initial multiplied by t or delta t, the time period, plus half a t squared. But we will take these equations in y direction. We will exchange a by g and x by y, or delta y, delta x by delta y. The time is the same, and the x in horizontal direction will be y in vertical direction, okay. Let us look at the first example. If we have a building, we have a free falling object from the top of that building, and the height of that building is 100 meter. It's okay to choose any height for this building. Okay, we have many points. I chose them arbitrary. Point 1, 2, 3, 4. The height at the first point is the same height of the building, which is 100. The height at the second point is 80 meters. The height at the third point is 20. The final height, which is h4, is 0. It is the ground. We need to find the velocity at each point. Also, we can find the time at each point using the equation of motion. Any one of them. Now, for this problem, for this object, v is equal to 0 at point 1 because it starts its motion from that point. So v equal to 0, or v1 is equal to 0. Also, we need to choose the upward direction as positive and the downward is negative. And we have the equations. Okay. If we need to find, for example, the velocity at the second point, using the second equation to find v2 and v3 and v4, it's okay. v2, I use the second equation. Why? Let us look at the first equation. v2 is equal to v1. v1 is 0 for all of them. So this term is 0, 0, 0. 0 multiplied by t. Okay. Why 0? It is 100. It's given. Y initial. But in the first equation, we know the g, the acceleration, which is negative 10. We can use it negative 10, okay? Or negative 9.8. It's okay. The time is unknown in the first equation, so we can't use the first equation. The second equation, also the third equation, we need to have the time, but we don't know it. But in the second equation, we have g, we have the change in position, y2, y1. We know them, okay? Now take a look. v2, the velocity at point number 2, squared is equal to v1 squared plus 2 multiplied by g, which is, I take it minus 10. I can take it also minus 9.8 multiplied by delta y, which is y2 minus y1. y2 is 80 at this altitude. y1 is 100. So we have, this is 0, this term is 0. We have 2 multiplied by negative 10 or negative 9.8, you can use it, multiplied by negative 20. This will be equal to negative with negative, it will be 0, positive, and the final will be 400 meter per second all square, because the velocity is squared. The units of velocity is meter per second, but we have velocity squared, so this unit is squared. We need the velocity, not the square of it. It is the positive and negative. In mathematics, it may be 2 will two values, positive or negative value. The root of 400, we have two values, positive 20 meters per second or negative 20 meters per second. Which value of them? The mathematicians will take that both of these values, but we are physicists. We know and we understand this problem. The sign means the direction. What is our direction in this motion? It is downward. The downward is negative direction. So we need to take the negative 20 meters per second. This is the right value. This is the wrong value because of the direction. Okay? This is 20. But if we take it, if we take G is equal to negative 9.8, the velocity will be, I'll calculate it, to 9.8 multiplied by 20 was if G equal to negative 9.8 منها V2 is equal to negative 19.79, almost 9, which is equal almost to negative 20 if we approximate it, meters per second. See why we always approximate G to negative 10 or to 10, not 9.8. It's okay, not that difference. Now, what is the time to reach point number 2? Time to reach from point number 1 to point number 2. In this case, we need to use another equation contains the time. We can use the second equation, the third equation, and the first one. The third equation, we have a squared term here. It will give load another step in solution. If we are in exam, we don't need to spend more time, so we will use the most simple equation. So I will use the first one. I can use this one. I have y initial and I have y final. I have G. Just I need to find T. I need to use another step, which is square root. Here, directly, V2 is equal to V1 plus GT. V1 is 0. V2 is negative 20. Is equal to 0 plus G negative 10 multiplied by T. Again, we can use it, negative 9.8. Now, we have to order our formula. It will be negative 20 is equal to negative 10 multiplied by T. We need to divide the both side over negative 10. Look, what if we use V2, the positive value, which is positive 20? It will be, in this case, this is positive 20, this is positive 20. The time will be in negative value. There is no time in negative value if we use the velocity V2 positive. Be careful, the sign has a meaning in physics. This is the time to reach the point number 2 from point number 1. It is 2 seconds. You can use these equations to find the velocity at each point, to find if the time from here to here is 2 seconds. You can find the time from 1 to 3, from 1 to 4, and then you can find the time periods between any of these points. Okay, so complete it, and we can complete another part in the class. Look, at this second example, as one in the book, if we have a thrown object from the top of that building with initial velocity positive 10 meters per second upward. Positive means upward. Then this object will reach a highest point, then it will fall again to reach the ground surface, and we have a hole or a well near this building. This depth is negative 20 meters. Okay, now we need to name the points. The starting point is 1, the highest point is 2, again the same highest, I name it another when the body return back to the same height, I name it 3, 4 at the middle of the building, 5 at the bottom of the well. Okay, there is a different points between one, there is a different situation between 1 and 3. Okay, we will see that now. Look what I need. Find the highest y, which is y at 2, with respect to the ground, this height. Find the velocity at each point. You can do it using the equations. Find the time at each point. You can do it. Okay, also if I order to find the time period from 4 to 5, or from 3 to 4, or from 2 to 4, you can find it. Okay, in this problem, V1 at this point is not 0. It is not 0, V1. The previous example, V1 was 0. But we have here V1 is not equal to 0. If you remember, one of the properties of the falling object, we have a velocity equal to 0 at a certain point. Where is that point? It is at the top, the highest point here, at point number 2. The velocity at the highest point is 0, which is at point number 2. Okay, and the acceleration always equal to g, downward, always, even at this point, even at the, look, at the highest point, the velocity is 0, but the gravitation is exist, and the acceleration is also exist downward in negative direction. By the way, I used it negative 10, not negative 9.8. It's okay. Okay, now the highest point, I need to find it, which is y2. I have the equations. Now I didn't name them v2, v1, or y naught. I named them as v final, v initial, y final, y initial, and we have also here delta y, which is y final minus y initial. Also the time here is the time period, delta t, which is equal to t final minus t initial. That depend on that part of that problem. Okay, we can use the second equation again. Why? Because we don't know the time, so we can't use the first and the third equation. We know the velocity, we know g, we need to know the altitude, y. Okay, the second equation, v final is equal to v initial plus 2g delta y. Okay, now to see, v final is v2 at the point, the highest point. V1 is the initial velocity, which is positive 10. This is V1. 2G, Y2 minus Y1, which is the altitude between the 2 points 1 and 2. طيب. Now V2, the highest point, it is 0. The velocity at that point is 0. V2 is equal to 0. V1 is positive 10, it is given. 2G, G I used it, negative 10. It is negative downward and I approximate it to 10. Multiplied by Y2 minus Y1. Y1 is the building height, which is 100. And Y2, it is the height of the second point from the ground. What we need to do now, we have now just one unknown variable. We need just to order our formula. 0, 10 squared is 100, minus 10 multiplied by 2, it is 20, multiplied by Y2, minus 20 Y2, minus with minus positive. Here we have 20, here we have 100, it will be 2000. Okay, now the negative term, I will move it to the opposite side, which is negative 2y. It will be positive 20y. I'm sorry, 20. Okay. What else? It is equal to 2000 plus 100. Now divide over 20. 2100 divided over 20, it will be equal to 105 meters. 105. Remember that the building is 100 and the altitude of the point number 2 is 105. So the difference in the altitude between the point number 2 and the point number 1, it is 105 minus 100, which is 5 meters. Okay, almost 2 floors. Okay, now let us complete. This is the part of our building. We can find T at point number 2. Look, they're required to find the velocities and the time at each point, at all the points. I will solve that for point number 2 and for point number 3. It is easy to complete that, I think. Okay, at point number 2, we need to find the time. Now, these are the equations. I don't know them yet, so I will write them on a paper and then I use them always. I cheat from them always. Okay. Also in the exam you will have a formula sheet. We can use the first equation. Also we can use the third equation, but we have a square term here. This will load another steps to solve. Sometimes we need to use the third equation, but now we will use the first equation. V2 is equal to V1 plus GT. The time here is the time from 1 to 2. Okay, V2, the velocity here is 0, as we know. The velocity at the first point is positive 10. G, I take it negative 10 because negative and 10 approximated, multiplied by the time period from 1 to 2. So we have 0 is equal to 10 minus 10t. I will move the negative term to the opposite side. It will be positive 10t is equal to 10. T is equal to 10 over 10, which is equal to 1 second. So this body spent 1 second to move from the top of the building to the top of the motion. Okay, from point 1 to point 2. Okay, now we need to find the velocity at point number 3, which is the same height as the point number 1, which is 100. Now again we can use the equation number 2. It is not complex. We don't need to complicate the problem. We need to use any equation suitable to our the required part. Okay. Question number 2. V final minus V initial plus 2G delta Y. V final now is V3. V initial is V2. V2 is equal to 0, if you remember that. So V3 is required to be solved. V2 is 0 plus 2G is negative 10. Delta Y. Okay, delta Y is for Y final, which is Y at 3, minus Y initial. Y final here is 100. Can you see that? 100. Here 105. So 100 minus 105. So V3 squared is equal to 0 plus 2 multiplied by negative 10 multiplied by negative 5. This will be equal to 100 meter per second squared. This is V3 squared. V3 is the root, positive, negative, the root. Again, the root of 100 is 10, positive or negative. What is the accepted value? The motion now is downward, so it will be negative 10. Look, the magnitude of the velocity at point number 1, which is the initial velocity, is 10. The magnitude of the velocity, which is the speed, at point number 3 is the same, because they are at the same height and the resistance of the air is neglected, or we don't care about it. The velocity or the speed without any direction is 10. The speed without any direction is 10 at the same height here. Okay? If we talk about the velocity, we need to put the direction. The direction is negative here and positive here. You can also find the velocity at this point, and you find that the speed here is equal to the speed here. The same. We will see that when we discuss the projectile motion. Okay, what is the time now? Again, we can use equation number 1 to find the time period from point number 2 to point number 3. This, to climb up, we spend 1 second. You will see that to go down again, we will spend also 1 second. So the flight time from point 1 to point number 3 is 1 second plus 1 second, which is 2 seconds. Now, how long the time from point number 2 to point number 3? We can use also again equation number 1. V final is equal to V initial plus GT. V final is V3, V initial is V2 plus GT, delta T. We need the delta T period, which is the time from T3 to T1. The velocity at point number 3 is negative 10. V3. This is it. Velocity at the highest point, V2 is 0. G is negative 10 or negative 9.8, it's okay. Multiplied by the time period. What we needed, the time period, all of it, but I write it here to know that the time period is from between 2 and 3. So negative 10 is equal to negative 10 multiplied by the time. Just divide negative 10 over 10, it will be 1 second. So the climbing time is the same as going down time. Again, you can find, now you know all the information, all the properties of the system at this point, then you can find the system unknown velocity and time at point number 4 and at point number 5. You have the heights. Okay. Do that by yourself, and good luck.